Good afternoon, everyone. I'm here to discuss the derivative of trigonometric function, assignment number 5. So the given in number 14 is solve for the derivative h of x equals tangent x over secant x minus 1. So first is we define the variables rule, which is this: the u of x equals tangent x and v of x equals secant x minus 1. So after we define the variables rule, next is we're going to find the derivative. So the derivative of u of x equals secant x, and the derivative of v of x is equals to secant x and tangent x. After we define the variable rules and find the derivative, we're going to applying the quotient rule. D over dx, quantity of u of x over v of x equals the derivative of x, v of x minus u of x, the derivative of v of x over quantity of v of x squared. So we apply the quotient rule to the function h of x. The derivative is equal to secant squared x multiplied the quantity of secant x minus 1 minus the quantity of tangent x multiplied by secant x tangent x over the quantity of secant x minus 1. So next we're going to simplify and expand the numerator. So we're going to talk about the one that in the up, which is the h of x equals the quantity of secant x multiply the quantity of secant x minus 1 minus tangent x multiply by the quantity of secant x multiply by tangent x, all divided by the quantity of secant x minus 1 squared. So to explain on how did we get or how did we expand the numerator, so we follow the steps on this paper. So as we can see, our numerator is on the top, which is the quantity of secant x multiplied by secant x minus 1 minus the quantity of tangent x multiplied by secant x tangent x. So I'm going to explain the step by step on how we expand each term in the numerator. So the first is the secant x multiplied by secant x minus 1. So that expands to secant squared x minus secant x. So the next expand is the second term, which is the quantity of tangent x and the quantity of secant x tangent x. And that expands to secant x tangent squared x. So we're going to combine the expanded terms. So that will be the combine the expanded terms to form the numerator, which is secant squared x minus secant x minus secant x tangent x squared x. And then we're going to write the simplified expression. The h of x equals to secant cube x minus secant squared x minus secant x tangent squared x over quantity of secant x minus 1 squared. So that's the step on how we expanded the numerator. The step that we should know or we should follow is the first is apply the quotient rule, and the second is expanded the terms in the numerator. So the step earlier is the step that we follow. That's the reason why I get this or we get this, that the one that in the bottom, the h of x equals to secant cube x minus secant x minus secant x tangent squared x over quantity of secant x minus 1. So after the expanding the numerator and simplifying, by simplifying, we will get the answer or the final answer. So the one that we simplified earlier is the h of x equals secant cube x minus secant x minus secant x tan squared x over quantity of secant x minus 1. So that's the equation that we simplified earlier. And the one that we simplified earlier is the one that the final answer. So the derivative of h of x equals tangent x over secant x minus 1 is equals to secant cube x minus secant x tangent squared x over secant x minus 1. So that's the final answer. Thank you for listening.